Hey, hello and welcome to today's GFG problem of the day, transform to prime. Let's see what the problem has to say. Given an array of n integers, find the minimum positive number to be inserted in array so that sum of all elements of array becomes prime. So what they are saying is, let's see through an example, right? So they are saying that we have to insert such an element to this array, right? To this array so that the sum of the elements after inserting that number, okay, the sum of the elements become prime. So let's say here the sum of array, right, for this particular, the sum of elements is 32. So what is the minimum number we can add to this sum, right? We can add to this sum which makes it prime, right? So the minimum number here is 5, right? Which, which after adding this 5 to the sum of element, this resultant number becomes prime, right? So we have to return that minimum number. Okay, we have to return that minimum number. So let's see through a code, right? How we can do first initial, right? So let's say we have this, we take a variable in sum, right? Then we go from I equal to 0 to n. Then we calculate sum, right? Sum air of I, right? Now then what we'll do, we'll have an a variable answer, right? And what we'll simply do is prime, sorry for that, sum. We'll pass sum. If it is not prime, then increment the sum and increment answer as well, right? Right. For sum, if it is prime, then we'll simply return answer, right? So let's say the sum here was 32. So what we'll do, we'll check whether this prime, if 32 is prime or not. Definitely it is not prime, then we'll increment to 33, we'll increment answer to 1, right? And then we'll again check whether 33 is prime or not. 33 definitely is not prime as it is divisible by 11. So we'll increment again, right? We'll make it 34 and we'll increment this, right? In that fashion, we'll keep on going until we find a prime, right? So here we'll stop when sum is 37 and answer is 5. When sum is 37, it is prime, then we'll return answer, which will be 5, right? Now the question is, how do we implement this is prime? How do we implement this is prime function? So if we go here, if we go and what Geeks for Geeks is recommending is, you have to use sieve of Eratosthenes, right? You have to use Eratosthenes, right? But Eratosthenes uses extra space, and here they have printed O of 1. So I'm assuming that this is wrong, and I'll go with the recommended solution. Okay. So let's see what is sieve of Eratosthenes, right? Right. So what Steve of Eratosthenes does is it it takes extra space, right, and stores all the prime numbers within that range. Okay, stores all the prime numbers within that range. So let's say first our range is, rather than this, right? Rather than this, our range is 51. Okay, okay. So what Sieve does is it has this buffer of boolean, right? We'll have this buffer of boolean, right, of 51 length. Okay, and first what we'll do, we'll mark that boolean, this array, right, this array as true. That is, all numbers are prime numbers currently. Okay, all numbers are prime numbers currently. And then what we'll do, we'll have a for loop, right, which will start with 2, right? Because definitely the prime number starts with 2. 1 is not a prime number, it's a composite number. So we'll start with 2, right? And for this 2, right, we will keep it as definitely as true, right? But the multiples of 2, what we'll do, we'll go to each multiple of 2 and we'll mark as false, right? Definitely, and 4, 6, these are not prime numbers. These are not definitely not prime numbers because they are divisible by 2, right? Right. So we'll mark all the multiples of 2, right? as false, right? Because they are not prime, right? We'll keep on going and we'll mark them as false. Then what we'll do, we'll write this internal for loop takes care of uh, making the multiples of the number as false. So if you see, initially we are going j equal to 2 into I. If I is 2, right? So we are starting with 4, 2 into I 4, and we are marking it as false, right? We are marking it as false. And then we are incrementing, right, j with I. So if it was j was 4, then we are incrementing with 2, right? 2, I is 2. Then we are again coming here 6, and then we are marking them as false. Okay, so this internal for loop uh, is making sure that we uh, set false to the multiples of the number, right? And then the outer for loop again, what it does is now it will take the next number, will keep this as is true, and multiples of 3, right? Multiples of 3, right? Will mark them as false. If some number, yeah, it will mark them as false, right? All the multiples of 3 will mark them as false. Okay. So in that fashion, we'll go till this outer for loop will go till root of the number 50, right? Root of the number, that is 7. We'll go till 7 because, right, because with root of the number, right, we would have covered, we'll have covered all the numbers, right? So 7, so when I say 7, right, 7 means this outer for loop will go till 7, right? And then internal for loop definitely will cover till all the number till 49, right? 49. So all the numbers are covered, right? So this is the approach behind sieve, right? This the sieve of Eratosthenes, right? So we'll use the same. So let's go through the code, right? So initially what we are doing is we are having this buffer, right? 10 to the power 6 we are going. We are storing till 10 to the power 6 as sum of elements go till the maximum range is 10 to the power 6, right? So we have this array, Boolean array. And what we are doing is this public function, right? First we are calculating the primes and storing the primes in our buffer, right? So here, as I said, we are setting first true, and then we are going to each number, right? We are checking if it is prime, 2 will be prime, and then we are setting the multiples of 2 of the number false. Similarly, we'll go from 3 to the right to the square root of that the max number, right? And then we'll set the multiples as false, right? So this is approach. Here we are storing the prime is prime, and then simply what we are doing is we are calculating the sum, right? And then we have this array, right, already, which we have stored. So this array now contains all the information, right, regarding the prime numbers, right? So so it is checking whether sum is prime or not. If it is not, then we are incrementing sum and answer as well. And finally, when we find some number as prime, then we simply return answer, right? So let me submit. So yes, it is accepted. Thanks for watching. Please subscribe to my channel and press the bell icon. Thank you so much. Thank you.